its magnitude is larger than a number without imaginary part. So one way is to make the imaginary part cancel each other. I take xl to be minus xt. Okay? If I do that, then the denominator greatly simplifies. Then I have PL is equal to half BT squared RL over RL plus RT squared. Okay, I don't need magnitude anymore because this is the real number. Okay, the imaginary part has cancelled each other. And what RL should I pick to make this the maximum? You have come across this problem before when you did resistive network. RL must be equal to RT. Okay, its maximum RL equals RT for maximum PL. So the two rules are that XL must be equal to XT, RL must be equal to RT, and the rule is that ZL must be equal to ZT complex conjugate. Okay? So this is slightly different from what you have learned in resistive network. That for maximum power transfer, you pick the load to be the complex conjugate of the Thevenin equivalent. Okay? And if you put that in, then you can actually simplify this to be 1/2 BT squared, and you can put this to be RT, and then this becomes 2RT, give you a 4, so it becomes 1/8 RT squared. Okay, and then this RT cancel each other. You get this to be your final formula. Okay, that is your final formula. And so that is the maximum available power. This is the maximum available power to be delivered to the load. Okay, in the textbook called PAB. Okay, and maybe we have time to do one example. Okay, I don't think I can do all the examples in the textbook, but let's just do one example. Let me see how much time I have left. I have some time left. Okay, example 4.23. If I do example 4.23, find the maximum power available from this circuit. Okay, so this is J3. This is 2 ohms. This is equal to 2 ohms. So the first thing you do is to convert this into a Thevenin equivalent. Find the open circuit voltage. What is the open circuit voltage? Assuming that this is open circuit, then this current must go like that over there. Okay? This current must go like that over there. It gives rise to a voltage drop across these two impedances. And then you have to add this voltage. So V Thevenin is V open circuit, must be 2 volts, 2 plus the other voltage drop, which is 1 times 2 plus J3. So this is the open circuit voltage, which turns out to be 4 plus J3 volt. Okay? And then the next thing is to find either the R Thevenin using test signal method, or to find the short circuit current. Okay? If you were to find the short circuit current, actually the example doesn't ask you to find the Thevenin equivalent, and actually asks you just to find the available power. Okay? Available power. And you can find R Thevenin or Z Thevenin very easily by using the test signal method. In the test signal method, you short this and you open circuit this. Okay, short this and open circuit this, and ZT is equal to 4 plus J3, right? If you short circuit this, open circuit this, and look inside and see what ZT is. And then you can find RT. RT is equal to 4. Okay? And then you use this formula to find the power available in this circuit. Okay? Then you can just available is equal to that formula over there, which is Vt squared over 8 RT. Okay? I won't go through the details, but maybe you still have some time left to do the last example. Okay, I'll have some time left to do the last example. Let's see if we can do that. Any questions so far? Any questions? If no questions, let's try example 4.24. Okay? And this is a rather complicated circuit again. And it's something that looks like that. Two IX, 1 ohm, and then the capacitance with the impedance of minus J, and then 1 ohm over here. Okay? You're asked to find the available power. So what are the steps you have to go through? Well, find the open circuit voltage. And I'm sure you know how to solve the problem. Next thing is that you can either find the short circuit current, okay, or you can find the Z Thevenin. Okay, if you find the open circuit voltage, I don't think I have time to solve this problem because it involves a few steps. Okay, so you find E open circuit by solving this using the node voltage method. Okay, this is E Thevenin. And then you find the I Norton, the I short circuit current by shorting this out, and you can find the current. Okay, and then you find ZT. And from ZT you find RT. And after you have found RT, you use that formula to find the available maximum power, which is Vt squared over 8 RT. Okay? Are there any questions? Instead of working out the details for you, I'd rather spend the last 2 minutes answering questions, if you have any questions. Are there any questions? I guess you're happy, right? No questions. You must be very happy. And yes?
What year were you born?
What year? I was very old. I'm much older than you. I have taught for about 30 years. Okay? So even the time that I spent teaching might be older than you.